the unexpected strikes. You need an insurance company that understands.
So we talked about surface analysis and then the view shed analysis, but I want to touch a little bit more on the surfaces because of their importance. Then we will go to the tutorial. Okay, so surface creation and analysis. This one is coming from ArcGIS. So but it applies. The principles apply. First, let's understand that every surface is made up of several values. Are you okay? All right. So when we create something like a contour, we are trying to represent a surface. Are you okay? Elevation values. When we create something like spot height, we are using points to represent a surface. Are you okay? So we can look at spot height and determine whether there's a valley or there's a hill. Are you okay? Or a ridge or something like that. So we can also create triangular irregular networks. That's also possible. Are you okay? When we use triangular facets to represent a surface, we have a tin, what we call a tin. It's like a net. Are you okay? And it's used a lot, like I said, in cartoons and 3D modeling. All right, so we can also use rasters to represent a surface. In that case, talking about digital elevation model, which I said we are going to work on today. So today you see how a DEM looks like. It's a picture, and then every single square has a value representing the costs, the height. The height is the cost. So if you are going up the Kape mountain, your costs, you have to spend more petrol. Are you okay? So the cost is the height. The elevation is changing, and it's changing rapidly. Okay, so it's important that in GIS we know how to handle this. There are programs in software that can convert points to public contours, okay, and then contours to raster. Okay, so there's a way to convert these things. Now, most of the time, you can also determine values at places where you don't have any values. We call that interpolation. So let's remember that interpolation is about determining the value of an unknown point. It's very important to take note of that. So if you have a straight line, then the points that you don't have values for, you can determine them by simply drawing, calculating, computing what the unknown value is. Are you okay? So if I know the value here, I know the value here. If this is 50 and this is 100, I can always determine the value here. Okay, by just looking at the distance. Okay, so if this is 20 kilometers, okay, then of course the middle is 10 kilometers. Are you okay? So this is 20. So interpolation makes sure that we can determine the height at this point, which is now going to be very likely between 50 and 100 is what? 75. Is that also? All right, so that is interpolation for you. I think we know this already, but I need to talk about it again. All right, so in surface analysis, in our bid to determine points of unknown value, we use interpolation. So in this example, you can see that to generate, all the values for points, okay, unknown values for areas, all these areas, we don't have the values, but the points have values. We use interpolation. Okay, and there are a couple of methods for interpolation. We have the inverse distance weighted interpolation, then we have the nearest neighbor interpolation. Are you okay? So IDW, and then we have the nearest neighbor. All right, so there are different ways of actually computing what the interpolation. These are not the only methods. Are you okay? We have the bilinear, the cubic, all these are mathematical formulas really trying to fit a curve, are you okay, to the points. But when you have a linear relationship, yeah, that's an assumption you are making. It depends on the surface, okay, if it's gently sloping. So we can make use of splines and trend lines, but at the end of the day, we generate a surface. In other words, the surface should have values across its extent, okay? So you can have, an elevation surface, you can have a heat surface where every point within the extent has the value of heat temperature, for example. Are you okay? And so we can create different surfaces. It doesn't have to be elevation only. But then at the end of the day, they all look like elevation surfaces, an elevated surface. We can also make use of density tools. We have what we call kernel density estimation that can help you to, convert your points to, raster. Are you okay? In other words, through interpolation, we're able to determine, areas which do not have values. What that means is that you end up having a 3D surface, which is also nice. Are you okay? So this is briefly what I wanted to touch on. I think I'll skip on this ones. And there are what we call the terrain tools. We can compute what we call the slope surface. In other words, you can have a surface in which every value of the cell tells you the rate of change. Are you okay? As you move from point to point. We can have a surface in which what we call the aspect surface. The aspect surface shows you the direction of the surface. Okay, so what direction is the slope facing? So you can look at, for example, a mountain and say, okay, in what direction is this side of the mountain facing? Are you okay? So that is the aspect. When you have a surface like that, it's called the aspect surface. You can have a hill shade. The hill shade, as I think we learned this in cartography. It's assumed that there's a light source, are you okay, which is coming from which shines light onto the surface from a certain angle, such that objects cast shadow and we get an impression of the shape of of relief. Are you okay? All right. So we can have these terrain tools, and then of course we have the curvature one. So as you can see here, we are having the slope. This one is a 3D visualization or rendition of this one. So this is okay. All right. This is a 3D surface, but this one is a 3D version of it. Okay. Now here we have a slope raster. So in this slope raster, yes, in 2 dimensions, you have it that way. In 3 dimensions, we have it that way. Okay. Now the slope raster is giving you what the direction. Oh no, sorry, it's giving you the rate of change. Okay. So the green, when you see green, it means it's almost flat. Are you okay? Not so much is changing over there. The highest changes are happening at the top
Oh,
of the mountain. So you can see
no,
the
what's
red
happening?
areas are having what?
Yeah, good morning.
The Someone doesn't know, you have to mute your mic. Please don't let me. I don't like these things. You are in a class. You can't be talking like that. Just mute your mic. This is the new normal, please. All right. So the aspect to calculate the direction. So you can see that in this one, direction, every surveyor knows that is 0 to 360. So 360 is the north. Are you okay? And 0 is also like the north. Are you with me? Because we start from the north and come back to the north. So north is 0 to 22. Are you getting that? Okay. East is going to be like 90, there about 270. Are you okay? West 270. All right. So in this particular surface, we have values that show direction. In other words, when we take the cyan color, it's pointing south. Are you okay? So north is always going to be north, the North Pole. Are you okay? All right. So these are interesting surfaces that can be generated. The hill shade allows you to see the surface like as if it's some solid that you can actually work. Like I said, it's a rendition. We are going to do the practical to touch on that as well. Okay, guys. So that is basically it. We can have what we call a cost surface. Are you okay? So I think we should be coming to that. You can do volume calculations as well. We won't have time to do all the cut and fill. We know what all these things are about. We have what we call the reclassification. Now take note of this one. Okay, so reclassification means that every raster has a certain range of values. You have the minimum value, and the maximum value. So if you actually take a particular extent, you can have the minimum height value, the maximum height value. So this is a range of values within which all the heights within the extent fall. All right. Now, what if you decide to actually classify the value so that you say that instead of 0 to 100, now you have 0 to 20 as one class, 20 to 40, what we do in statistics. The same things can happen here. So in this example, when you look at here, come down here. We start with this surface and then we reclassify it into about 1, 2, 3, 4, 5 or 6, classes. Are you okay? And then, so here we're talking about what? Ordinal data, that concept of ordinal. There's, a certain sense of classification, order. Are you okay? So now we can now say that maybe 0 to a certain number represents, with a certain color. So every color is representing a particular classification. So here we are even classified into 2 classes. So you can see that if you look at it closely, it's the same data, but all these light blue to the, deep blue, navy blue, the sea blue or whatever, I'm not colorblind here. All that is being merged into the gray values. Are you okay? So that is the idea of classification, if I reclassification, because every data is already classified somehow. Are you okay? But we reclassify most of the time. You do reclassification for size selection, and for that reason, I want us to, if we are not able to finish this lecture today, this practical today, I want us to continue next week. All right, so that we can do more practical. I want to show, especially suitability analysis is one of the very important things I think we need to do in this class. So we'll be using the reclassification, applications available to us to appreciate how you combine different layers. Are you okay? And then determine the best area that is suitable, say for agriculture, for waste dumping, and for all sort of applications where we need to choose where to, the best places to get something done. Are you okay? So we can also use what we call the distance tools, which actually talk about cost distance, cost path, cost backlink. All these things are also available. Proximity analysis and all these things are there. Are you okay? We can do map algebra. Map algebra is like, it allows you to add one raster value to another value. Are you okay? Because raster is just values. So the map algebra really is about that, being able to apply the same, addition, subtraction, division, even apply some trigonometric functions. Are you okay? To our data sets. Are you okay? All right. So, yep, there are a whole lot available for us for surfaces. Are you okay? And so I wanted to touch on this before we actually go into our practical. Let me see if there's something that I still haven't touched on. Okay, so you can see that there's a whole lot that can be done, but we can't go on all that at a go. Are you okay? There are hydrology tools, so you extend into remote sensing somehow. And so if you are going to be doing a project in GIS, then you need to be taking this material serious. I think I've given it to you. So please, let's read it, appreciate it. Are you okay? And the basic is the students should be able to appreciate the surface, what the surface is. And then once you appreciate that, the sky is the limit. There's a whole lot that you can do, like you said. Are you okay? All right. So, yep. A cost surface, for example, we'll just look at the cost of traveling from one point to the other. We won't do that. We'll look at that today. We'll look at it. Hopefully, maybe next week. Depends on how this one goes. Is that all right? Okay, so if you have any question, you can ask